Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will see energy store in capacitor. We know capacitor is a device which is used to store electrical energy in the form of charges. Now it store energy when it is connected to the battery and it releases its energy while discharging. So let us see. Let us consider the capacitor. Capacitor is nothing but it's a parallel metal plates. It's a combination of metal plates or conductor. Now initially there is no charge on the capacitor. So when we are connecting to the ground, we'll say the potential of this capacitor is 0 or on the metal plate is 0. Now we are connecting this metal plate to the battery. So there is the charges. Now these charges will pile up on the metal plate. But now when it is coming out, these charges when it is entering, there is a repulsion between the charges which are already present on the metal plate. Hence, these positive charges will push the incoming charges. So to enter these incoming charges on the metal plate, there is some work is done. Now, if we connect this to the potentiometer, then we can see some potential is here. Means the potential is here. Now we can say it is a V. So during this process, during the charging of capacitor, some work is done. Now we will see Q is a total charge on a capacitor. V is a potential difference between the plates. Now we know during this process some work is done. So we'll know here that is the potential is equal to work done per unit charge. Hence we can write here work done W is equal to V into Q. Now for small amount of work done, it carries small charge dQ. Hence, amount of small work done carrying a small charge that is dq. So here we will find out what is the total work done. So total work done W is equal to integration of small work done. So here we know work done is nothing but V into Q. Now here we are considering small work done. Hence, we can write here integration of V dq. Now, we know capacitance C is equal to Q upon V. Hence, we can write V is equal to Q by C. Hence, we'll substitute this value here, that is Q. But here we are considering small amount of charge, so we'll write here Q by C. Hence, instead of V, we will substitute Q by C into dQ. Now, this C is a constant. So, 1 by C is a constant. Integration of Q into dQ. Now, this charges starting from 0 to Q. So, let us integrate this. Q dQ, 0 to Q, Q dQ. Hence, we have here Q square by 2. 1 by C is a constant and its limits are 0 to Q. Hence, here we will get 1 by C and 2 is again constant, so this will come out. Then here we have Q square. Hence, we can write W is equal to Q square upon 2C. Again we know C is equal to Q by V. Hence, Q is equal to C into V. Let us substitute value here. So we have here C square V square upon 2C. The C will get cancelled. Here we have CV square upon 2. Hence, we can write here 1 by 2 CV square. This is the total work done by the capacitor, or we can say now this work done is stored in a capacitor as a energy E. Hence we can write E is equal to half CV square. Let us substitute the value of C here. C is equal to Q by V. Hence, we will get here E is equal to 1 by 2. If we substitute Q by V, that V will get cancelled. That is Q by V into V square. So, this V will get cancelled, and here we have equation E is equal to half Q into V. So these are the two equations to find energy stored in the capacitor, and it depends on the capacitance and the potential difference as well as the charge and the potential difference. Thanks for watching this video. Stay tuned with Ekeeda and please subscribe Ekeeda. Thank you.